And here, I'm going to write at the top again, we're always thinking about factoring first, even if it's not available. And in my first example, it won't be available. And then how do we simplify fractions? Well, you can simplify fractions if you can reduce to lowest terms. So we look at numbers first. In A, draw my fraction line. Can you see that you could reduce 25 over 35? They both divide by 5. So if I divide the top by 5, I would get negative 5. If I divide the bottom by 5, I get 7. So the numbers part is just like regular fractions, and you had to reduce it to lowest terms. You try to find the biggest number you can divide by. And sometimes you can't see the biggest number right away. It's okay to do it in more than one step. Do you ever do that? Like, oh, I can divide by 2. And then like, oh, I can divide by 2 again. Instead of starting by dividing by 4, you might not see. So that's okay as well. Then when you get to your variables, you can either use your exponent laws, or you could just sort of use logic in a way. Like exponent laws say, when you're dividing bases with the same power, same bases with different powers, what do we do to the exponents? We subtract the exponents, right? Because if you had something like x to the 8 over x to the 5, you would get x to the 8 minus 5, which is x cubed. That's the rule for an exponent rule you learned in grade 9. You can use that exponent rule, or you can also just, and this is, I think, a really easy way to do it, is visualize that if I had x to the 8 over x to the 5, I would visualize in my head, well, this is like having repeated multiplication. Oh my goodness, I need one more. Of 8 x's all multiplied by together. And x to the 5 would be, and I never write this out, I just sort of visualize it in my head. But this x would cancel out and simplify with that x, and this one with this one, and this one with this one, and this one with this one, and this one. And it makes sense that we're left with 3 of them. Which is the same as subtracting, but sometimes this is nice, especially if the exponent is bigger in your denominator. So for example, a cubed and a, you're going to be left with more on the top. How many more on the top? A squared. Does that make sense? I like that visualization because you're like, okay, that makes sense. Sometimes we need the rules because you're going to get into some questions where they might play around with fractions or decimals, and then the rule comes in handy there. What about the b's? Do you have more b's in your denominator or your numerator? We have more b's on the bottom. How many more? 3 more. Make sense? And then we still have a c left on top. This is simplest form. So the first one, it was all multiplication. We didn't have to factor. The second one, I'll just change colors here so that we don't get mixed up. On the top, I recognize that I have a common factor, and I'm going to do this one in a couple of different ways. I'm going to do it proper, well, not proper, but like what would be expected of you when you factor. And then I'm also going to be like, show you a different way if you like it as well. So on the top, between 6 and 12, there's a common factor of 6. So I could pull that up. Between x squared and x, I could pull out an x. That would leave me with just an x there, plus 2, divided by 3x. So we could factor this, and then once it's factored, you can simplify if you have factors that are identical. And you can simplify numbers, but only if you're multiplying. So here we have 6 times x plus 2. So I would be able to do, what is 6 divided by 3? That's 2. What happens with my x's? They would simplify. And I would still be left with my x plus 2 on the top, which makes this 2x plus 4. This is using factoring. Draw a line.
Your homework?
I did.
Oh, you did it?
Yeah.
We can talk later.
Yeah.
Just was curious.
Yeah, I found a few things.
Okay, good.
Second, you could use a different strategy of factoring. If you see that you have a 3x on the bottom, and you're like, hey, look at this, I could pull a 3x out of the top, and I still have the 3x on the bottom. 3x pulled out of the top would leave me with 2x plus 4, and then my 3's would go away, my x's would go away. That's kind of cool. That kind of gets me my answer a little bit faster. 2x plus 4. Or we could use a strategy of what I call unadding fractions. When you're dividing by a monomial, this is the same as saying the 6x squared needs to get divided by the 3x, and the 12x needs to get divided by the 3x. Because how do you add fractions? When you add fractions, you get common denominator and add the tops. I call this unadding fractions because you broke it up to what it was before, and then when you break it up, you're like, hey, what can I do in my first fraction? 6 divided by 3 is 2. X squared divided by x is x. Second fraction, 12 divided by 3 is 4. X divided by x would go away. And we get the same answer sort of in 3 different methods. All of them work. Take what you like from one over the other. There are places where each one of these strategies is probably better than the other ones. So when you have multiple strategies, think about them because they could be like, maybe there's something I would like to use over another. But generally, you're going to find for a lot of these questions, you have this idea of factoring first, so then sometimes you don't think about this last method because you're so focused on factoring first. Okay, I'm going to do the third one in green. Again, I'm going to factor first here. The top is a difference of squares. The bottom is going to be x and x. And this unit has like hints built in. They want you to simplify. So what do you think one of these numbers is going to be? I'm pretty sure it's going to be a 7. Can I make 7 with 14? Well, it would have to be 7 and 2. Now I need my outside and my inside to make minus 5, so I would mean a minus 7 and a plus 2. And again, do a quick multiplication every time you factor, because you make one factoring mistake in these questions, and the whole question can go bad very quickly. But now that we're multiplying, we are allowed to simplify. We can simplify only if we're multiplying. And I'll show you some real number examples, because do you know what's going to happen to some of you? Some of you are going to be tempted in one like C to be like, ooh, x squared and x squared, I'll just make them go away. That's going to be really bad. It's going to be like the best mark you could get is 0 if you do something like that. The best. It doesn't matter if it's out of 1 or out of 50. The best you're going to get if you do that mistake is going to be 0. It's going to be catastrophic. Why can't we do that? Well, when we're adding and subtracting, you can't simplify. For example, is 5 plus 1 divided by 5 equal to 1? No. Like, this would be catastrophic, wouldn't it be? 5 plus 1, right? Or maybe, let's do one we can actually do the math. Like, 5 plus 10 divided by 5. I hope you see that the answer to this is 3. Right? Because 5 plus 10 is 15, and 15 divided by 5 is 3. But if you go and say it's 10, that's really wrong. It's not even close to being right. But if you were multiplying 5 times 7 divided by 5, well, 5 times 7 is 35. What's 35 divided by 5? You get 7. If you're multiplying, this is okay. So one of the reasons that we factor is so that we can change things to multiplication, and when factors are identical, like in these numbers, it's perfectly fine. Because if I get you to do some mental math, are you ready for this? Right? Okay? You'll be 19 times 33. Okay, got it? Now divide by 33. What do you got? 19. Amazing mental math skills, right? He's like, how quick you got that 19 times 33? And then, that's a huge number. He divided that by 33 and got 19,000. I was impressed. Right? Because when you multiply by something and then divide by it right away, it goes away, right? But if you add something and then divide, it's like, oh, that doesn't just go away. Right? Because if I was like, what is, if I said, what's 133 plus 12, now divide by 12, you don't get 133 anymore. It's like, oh man, now mental math is painful. So be careful with that because you will be, like, it makes total sense for you when it's written like this. You have to do the 5 plus 10 first and then divide by 5. Like your order of operations makes sense to you. But you are going to be tempted to do this, like, ooh, 3 and 9, I can simply, no. Catastrophic, right? Unless you're like striving to get zeros on as many questions as possible, but don't want to leave them blank. This is a good strategy. You can show lots of work and get 0. Not very often that happens. But anyways, once we've canceled this out, what's left? We're left with x plus 7 over x plus 2. Now, if you look at the answers at the bottom of the page, and I'll be really explicit with this, but on the bottom of the page, they've also put a comment after these questions and said not x, but they said like A can't equal 0, B can't equal 0. So they're simplifying it and they're listing their non-permissible values. For you, if I say simplify, you don't have to list the non-permissible values. I'll be very explicit. I'll say simplify and list the non-permissible values, or I'll make part A list all the non-permissible values, part B simplify it. But that's the reason why in the first one they wrote those. In the second one they would have written x can't equal 0. And in the third one there are 2 non-permissible values. X can't equal 7, and x can't equal negative 2. And when we get to part D here, again, we're going to factor completely. Ooh, I think this one's going to have something interesting happen. The bottom is a difference of squares, but since the 9 is first, it would be 3 plus x, 3 minus x. The top has to be 2x and x to get a 2x squared. Again, you probably didn't notice, but I checked if there was a common factor to pull out first. Yes, question.
Did we ever use the quadratic formula for like the top part?
Because this is a simplifying question, it's either you can factor it or not. If you can't figure out how to factor it on a separate piece off to the side, you could use the quadratic formula. And if you got, for example, in this one, in the green one, if you got x equals to 7, then you would know that x minus 7 was a factor. So if you use the quadratic formula is for solving an equation. There's no equal sign here. There's nothing to solve. So we have to check if we can factor it. So it is important that we get good at our factoring skills. Let's see, if I put 1 and 3 here, I need a minus 5. So my outside will be minus 6, my inside plus 1. That still gives me the right answer when I multiply it up. If you use the quadratic formula, you would have got x equals negative 1/2 and x equals 3 as answers. And then you'd have to use that to figure out what the factors were backwards. It is much faster just to get really good at factoring. Develop those skills. Now, are any of these identical? No. Okay? So technically, we cannot cancel out anything that is not identical. However, maybe we want to write this as a special note. And you recognize the special note when things look really close. Like you see, oh, here I have an x minus 3, and here I have a 3 minus x. The special note says if you have something like that, take the 3 minus x and pull out a minus 1. If you pull out a minus 1, do you see that that would make the inside the 3 negative and the x positive? So if the x is positive, I'm going to write it first, and the 3 is negative, I'm going to write that second. That makes negative x minus 3. So I'm going to take my whole equation, I'm going to rewrite the top. It doesn't take too long. Some of you will try to take shortcuts, and I'll tell you don't do that, just rewrite it. And I factored out this negative 1, and now I have x minus 3. Now these are identical. So you would be asked to recognize when that happens, that special note, if two factors are basically the same, but they're sort of, they're mixed up the numbers when you're subtracting, then you can factor out a negative. And so how do I write this in the end? Well, on the top of my fraction, I have it 2x plus 1. On the bottom of my fraction, I have it 3 plus x, or I like to write the x first, so I'd probably change that to x plus 3. And on the bottom, I also have a negative 1. You can put that negative 1 either as a negative here, you can put the negative on the top, or you can, in a fraction, put the negative out in front. It wouldn't matter, I would accept all three of those. And since I had the negative on the bottom, I probably would have just kept the negative on the bottom. Questions for practice on this one? 7 and 11.